Hello everyone, today we'll talk about the solution of the problem shortest distance after road addition queries 1. The statement is actually quite simple. We are given some cities on a line, the 0th city up to the n-1st city. At first we can only go one step from any node to its immediate neighbor to the right. And we are always interested in the shortest path from 0 to n-1. So at first it takes n-1 edges, because we have n nodes and one fewer edge. And the interesting part is that we are given a list of queries, and every query modifies the graph permanently by adding a new edge. And then after every query we have to answer what is the shortest path from 0 to n-1. Now, it's obvious how to calculate the value for that path for the graph at any position, at any point in time. We can either just run a BFS from 0, or we can run a simple, essentially dynamic programming. We can just go through all the nodes from 0 to n-1 because they are topologically sorted by default. By going from 0 to n-1, we have a guarantee that when we are visiting a node, we have also visited all the nodes that have been visited previously. Although those edges, we are not being told that those edges can go to the left, so there might be some caution required at this point, so maybe it will be best to use a BFS from 0. But this is a brute force. We have to modify after every query the graph and then recalculate the distances. And I'm not aware of any solution that actually utilizes the fact that most of the stuff that we have calculated is probably going to stay the same after the addition. And this problem does not require anything better than that. So the solution that you can send, and that solution will pass, and is probably the intended solution, is just to recalculate those values after every query, and maybe do it in a smart way so as to not write too much code. And one easy way to get rid of most of the complexity that we can have is that after we add this new road, then we can go through all the nodes from the node that the new road was pointing to up to the end, update the cached results from the first run, which is of course the starting results is we know for every node, is just the distance from it to the final node when it comes, just the difference between their numbers. And so we start at the last node of the new edge, and we go up to the last node of the whole graph, and recalculate their values of the shortest path to reach them. And at the end we just always return or add to the result the value for the n-1st node. So we'll be maintaining those values. At first, again, it's 0, 1, 2, and so on. So the final answer for n-1 is n-1. That's the shortest path from 0 to that node. And we have a graph that remembers the edges that come into every node. And when it comes to remembering the edges, it's just that every node, except for the first one, has an edge from the previous node. And of course we'll be maintaining the result, because at the end we have to return the result for every query. And now for every query we add this new edge, so we just append to the graph of the target node this edge, and we just recalculate for everything from the target node up to the end its result. And we recalculate it naively, so we take its cached result to be the minimum of its previous cached result, and the minimum cached result for anything that has an edge to it, so for every neighbor in its graph. And of course we have to add 1, because we want to get the result from some node that can reach our node in a single step, and then we have to add 1 for this single step. And at every query we append the result for the n-1st node. So this is essentially the brute force naive solution. We just do the same thing for every query, but this is sufficient for this problem, and I'm not aware of anything that's significantly better than this.